Okay, welcome back again. Now, in the previous class, we had studied about the rules. So many rules I had taught you. 3 rules for concave mirror, for constructing ray diagrams in case of using concave mirror, and 3 rules to construct ray diagrams using convex mirror. Okay, now we are going to apply these rules today for making ray diagrams. Now, what is a ray diagram? Ray diagrams are constructed to find the position of an object, find the position of the image for any object placed in front of, in this case, concave mirror or convex mirror. Okay, while using these mirrors, when you focus the object using mirror, where will the image be formed? Okay, for that we need ray diagram. Okay, the actual happening where the object is, where the image is for a particular object, that determination of the image we can actually find out by drawing ray diagrams. So for drawing these ray diagrams, the rules which I had given you in the previous class is necessary. So today we will apply it. So I have given here the heading. I hope you can see ray diagrams for formation of image. Okay, for first we will do for concave mirror, and in concave mirror the first case that I have taken is when the object is at infinity. Now what do you mean when an object is at infinity? The word infinity here in this context is very far away from the mirror. When an object is very far away from the mirror, then when an object is at infinity or very far away from the mirror, parallel rays of light will come from it. Okay, you can see over here there is no object drawn because object is at infinity. We don't know how far it is, so we cannot draw the object. But parallel rays coming out from this object, those parallel rays I have drawn over here. Okay, you can see 1, 2, 3, 4, 5, 6 incident rays are there coming from the object which is at infinity. Keep in mind, when object is at infinity, parallel rays of light come from that particular object. So here, these 6 rays are the incident rays coming from the object, which is very far away from the mirror, concave mirror. Now, yesterday we learned that when a ray is incident parallel to the principal axis, see all these rays, are they not parallel to the principal axis? This is the principal axis. Okay, this series also they are parallel to the principal axis. So, according to the rule, the reflected ray coming out from any ray parallel to the principal axis will pass to the focus or will meet at focus. Okay, any ray parallel to the concave mirror, any ray parallel on a concave mirror to the principal axis, parallel to the principal axis will reflect and meet at focus. So there are 6 rays over here. They are parallel. All of them are parallel to the principal axis. After reflection, see I have drawn here. After reflection, all of them come and meet at focus. Now you can do one very interesting thing using this particular concave mirror. If you have one at home, if you have a concave mirror, concave mirror, the example is a spoon. If your spoon is a highly polished spoon, the curved side which is facing you is a concave mirror, and if you reverse it, this bulging side of the spoon is a convex mirror. So if you have a concave mirror, you need to have a mirror like how you have plain mirrors made up of glass, like that. Curved mirror, if you have made up of glass, concave mirror, you can do this particular experiment. Now what is this experiment? What you do is, you bring a piece of paper and put it in front of this concave mirror. You have to check, you have to keep on moving the position. The point where you see the image of the sun on the paper, okay, you keep on moving the paper this way in front of the mirror, and suppose this is the paper, I keep on moving it, provided this side is facing the sun. Okay, the mirror's reflecting surface is facing towards the then I keep on changing the position of this paper. As soon as I bring it towards the focus of this concave mirror, at focus what happens? The image of the sun will be focused on the focus. Okay, the image of the sun will be focused on the focus, and I have kept the paper also on the focus. So as soon as the paper is on the focus, it will start burning. The paper will catch fire. You know why? The entire sun, the sun is the object in this case. Okay, the entire sun, from the sun parallel rays of light coming, will focus. The entire sun's image will be focused on this focal point. So the temperature of this focal point will be very high. You may have done a similar experiment using a magnifying glass. Have you ever burnt a piece of paper using magnifying glass? By focusing the sun's rays on to one spot. At that spot you will see one small dot of the image of the sun. And the temperature at that point where the dot comes is very high. If you place a paper, the paper starts burning. So in this case also you can do the same experiment. This is not a magnifying glass, this is a concave mirror. If you put a paper at the point where the focus of this concave mirror is, then the image of the sun will be formed at focus, and if you place a paper over there, the paper will catch fire. The entire sun is focused over here. So the temperature, the heat rays coming from these rays will be focused on this point, and the temperature of this point will be very high and the paper will start burning. Okay, now few things that we need to know about the image which is formed at focus. Okay, the object is at infinity. Where is the image? At focus. The image will be very small, as I said. The image, if you focus, if you point this side, the reflecting side towards the sun becomes the object which is at infinity, and the image of the sun which is at focus is a small dot, very small. Okay, so the image is highly diminished. Diminished means smaller than the object. Diminished means smaller than the object. Okay, the second one that I have written about the image is it is real and inverted. Now I am going to discuss this point in the later part. As of now, you just keep in mind that the image is real and inverted. I am going to discuss what is a real image, what is a virtual image. These are also there, but first of all, let us finish this topic. Okay, the third thing that I have written about the image is where is the position of the image? Where is the image? At focus. So these are the three characteristics of image. The image is diminished, that is highly diminished. The image is real and inverted, and the image is at focus. Okay, now the second case is when the object lies beyond center of curvature. In the previous section we saw that the object was at infinity, very far away. So we could not actually draw the object. Now here you can see this is the concave mirror, this is the principal axis, center of curvature, pole, and where is the focus? The focus is always in between center of curvature and the pole. So I have drawn the focus somewhere in the middle. Okay, now according to this statement, the object is beyond. Beyond means little bit away from. Okay, so I will place the object somewhere here. Now you might feel this as strange. What sun is drawn over here? The object, the arrow sign in this line symbolizes that the object's head is towards the upper side of the principal axis. Like for example a tree. So the roots of the tree will be downwards and the branches will be on the top. Or a house or a man, the head of the man will be on the top and the legs down. So this is the object. It can be anything. So I have in general drawn a line with an arrow. Arrow indicates that the head of the object is pointing upwards or above the principal axis. The head of the object lies above the principal axis. Now we will construct or we will choose one particular point. Okay, the tip of the object, say here, because we cannot draw ray diagrams for all the points in this object. It will be too hectic for us. So we are going to choose only one point on this object from where we will draw two rays following the ray diagram and see where the image of this object is formed. Okay. So now first ray, let us assume from this particular point the head of the object parallel to principal axis. So one ray coming out from this tip of the object parallel to the principal axis. And according to the rule, what do we know? A ray which is incident on a concave mirror as parallel to principal axis, from where does the reflected ray go? It goes through the focus. So I am going to draw the reflected ray which passes through the focus. This is the reflected ray. Alright. Next, I am going to draw another ray from the same point from where the incident ray has been drawn over here, from this point. This time, it will pass through focus. Okay. And what do we know about any ray in a concave mirror which passes through focus? Incident ray which passes through focus. First, let me draw that ray. Okay, here is the incident ray which passes through focus. I hope you have studied those rules. Unless and until you study those rules, you will not be able to understand anything here. Okay? A ray of light which passes through the focus and then falls on the mirror, after reflection becomes parallel to the principal axis. Here, this was the ray, incident ray which passed through focus, hit the mirror, and after hitting it reflected and became parallel to the principal axis. So we have now two rays. I have drawn two rays over here. One is parallel. I have chosen one particular point from the tip of the object. One is parallel, incident parallel to the principal axis. After reflection, pass through focus. Another ray from the same point, but this time it passed through focus and after hitting the mirror, it reflected and became parallel to the principal axis. So these two reflected rays meet here, and this is the point where the image will be formed. Image of this particular object. Okay, this is the object for us, and here will be the image. And this time the image. See, in this case, the image was drawn starting from the principal axis, above the principal axis. Now the image will be formed at this point where the two reflected rays meet. Where they are meeting? Below the principal axis. So, from the principal axis, we are going to draw a line perpendicular to the principal axis on this particular point where the reflected rays are meeting. See here. Here is the image of this particular object. So this is our image. Remember, where will the image be formed? The image will be formed where the reflected rays meet at a point in front of the concave mirror. Such image which is formed by the actual meeting of the reflected rays is called a real image. Remember, in the previous section I was telling you that I will tell you what is the meaning of a real image. A real image is formed by the actual meeting of the reflected rays. These are the incident rays, these are the reflected rays. The reflected rays actually cross or meet each other. The point where they cross or meet each other, there will be the image. Alright? I hope you are understanding. Now, let us discuss the characteristics of the image that we have formed by using ray diagram. The image is, I am talking about the image when the object lies beyond center of curvature. The image is number 1, it is real and inverted. I hope you understand now why we say that the image is inverted. Check, the object was standing this way, above the principal axis. Head was above and the tail was below, touching the principal axis. The image now is ulta, opposite. Now here it is below the principal axis, the head is below the principal axis. So it is not as the object above the principal axis, it is inverted. That's why we say image is inverted. And it is real. Why? What did I say a real image is? A real image is that image which is formed when the reflected rays actually meet each other. The point where they meet after reflection. That's the point where a real image is formed. Okay, the second characteristics of this image that is formed. Can you not see that the size of the image is little smaller than the object? This is the object. See the size of image. Is it not little smaller than the object? So we will write diminished. And the third characteristic. What is the third characteristic? Position. Where is the position of this image? Notice one thing in the previous section. Okay, I'll show you. In the previous section, the image is formed at focus. All the reflected rays are meeting at focus. So wherever the reflected rays are meeting, there's the position where the image is formed. Now, the image is formed. The image has now shifted. Okay, the position of image has shifted now away from focus. Now it is between center of curvature and focus. So the position of the image is in between center of curvature and focus. So we realize one thing over here. As we bring the object closer to the mirror, the image is now shifting away. As I showed you, no? In the previous case, where was the image? Image was at focus. Now it has shifted a little bit because the object has been brought closer to the mirror. Now image is moving away from the mirror. So right now, where is the image? Between C, that is center of curvature, and F, that is focus. Okay, now we will see a third case. In the third case, we will further bring the object even more closer to the mirror, the concave mirror. In the earlier case, we saw that the object was a little bit far away from the center of curvature. Now, what will happen if we bring it and place it at center of curvature? Okay, now the object, let us put it at center of curvature. This is our object. Again, the head of the object is above the principal axis, and we are going to choose one particular point that is on the tip of the object. From there, we are going to make two incident rays coming towards the mirror. Alright, one ray parallel to the principal axis. One ray parallel coming incident parallel to the principal axis, hitting the mirror. It will pass through focus as the rule says. This is the reflected ray, it passes through the focus. Incident ray parallel to the principal axis, the reflected ray passing through focus. Now the second ray we will take, we are going to take, which will be incident towards the mirror after passing the focus. After passing the focus. Okay, this is the incident ray coming towards the mirror after passing the focus. After it crosses and hits the mirror, it will reflect. And in which direction it will reflect? As if it is parallel to the okay, after reflection from when the incident is passing through focus, after reflection it becomes parallel. Now we have two reflected rays over here. See, this is the first incident ray, this is the first reflected ray. This is the second incident ray, this is the second reflected ray. Both of them come and meet at this particular point. So I have constructed an image at this point, and you see the object and the image. This is the object and here is the image. Both are on the same point, that is on the center of curvature, C. Okay, C for center of curvature. So this is the point where both the object and the image are at the same place, that is the center of curvature. Not only that, the size of the object and the size of the image both are equal. So this is a special case. Before this, we had seen that when an object is beyond center of curvature, the image used to be a little bit smaller compared to the object. Now both the object and the image are of the same size. So when this happens, when the object is at center of curvature. And notice one more thing. We have now brought the object even a little more closer to the mirror. Now the image size has grown. All these while we were seeing that the image used to be smaller than the object. Now object and image are of the same size. From this, if you bring the object even more closer, the image, the size will start getting bigger and bigger. Okay, the size of image will start getting bigger and bigger. So let us write the characteristics of image. The image is, first of all, is it not a real image? What did I say real images? When the reflected rays actually meet at a point in front of the mirror, then the image that is formed is called a real image. So in this case, the reflected ray, these are the two reflected rays, they are actually meeting. So the image that is formed by actual meeting of the reflected rays. So it is a real image. And real image is always inverted. See, the object was above principal axis, the image is below principal axis. What is the second characteristic? Okay, the second characteristic is the size. The size of object and image are now the same. The image is equal in size as the object. And the third characteristic, what will it be? The position of the image. Where is the position of the image located? The object is at center of curvature, the image is also at center of curvature. So this point, the center of curvature, the image is also at center of curvature. Okay, now we will come and see the fourth case. In the fourth case, we are going to bring the object even more closer to the mirror. Before we saw the case where the object was at center of curvature. Now we have further brought it even more closer to the mirror. Now it is here somewhere between C and F. C means center of curvature and F means focus. So when the object lies between center of curvature and focus, again we are going to apply those same rules. one ray parallel to the principal axis. After reflecting, it goes and passes through the focus. One ray parallel to the principal axis from this same tip from where we have been drawing the incident ray. From this same tip, one ray is taken parallel, incident parallel to the principal axis on the mirror, and after reflecting, it passes through this focus and goes. Okay, so this is the reflected ray. Now the second incident ray, I am going to make it pass through focus. This is the second incident ray, and after reflecting, where it goes according to the rule. And once again, I am reminding you, please study those rules which I had given in the previous day. So after reflecting, it will become parallel to the principal axis. So let's try to make it parallel. Okay, here is the reflected ray. So we have two reflected rays. This is the first reflected ray. This is the second reflected ray. Both meet at this particular point. So the image will be at this particular point, and you see the object. This is the object over here. It was pointing above the principal axis. Now the image which will be there will be below the principal axis. So that means it will be an inverted image. Here is our image. And as you can see, the image is actually formed by the actual meeting of the reflected rays. So this is a real image, and real images are always inverted. So it is real and inverted. And about the size of the image, now this is the object. See, the object is of this much size. The image now became bigger than the object. Remember, I had told, as you bring the object closer to the mirror, the image is going to get away from the mirror, and the size of the image will keep on becoming bigger. So let's try about the characteristics of this image. Number one, it is real and inverted. Number two, what's the size? The size is now, we will not write diminished or equal, now it is bigger than the object, or the word is magnified. Magnified means bigger, in this case it means bigger than the object. Magnified means bigger than the object. Okay. The third characteristic is, where is the location of the image? The location of the image, here is the image. Where is the address? The address is somewhere near C, center of curvature, beyond center of curvature. Remember, we had this second case where the object was beyond center of curvature and the image was between C and F. Now it is the reverse. Now the object is in between C and F and the image is beyond center of curvature. The last case for concave mirror is when the object is at focus. Now we have brought the object even more closer. Before it was at infinity, then beyond C, then at C, then between C and F. Now it is at focus. Okay, when it is at focus, what happens? What kind of image you will get? So again, let us do the same thing. One ray parallel to the principal axis. reflecting passes through focus. Okay. Now, for the second ray, I cannot take one ray passing through focus. It will go like this. If it has to pass through focus, it will never come towards the mirror. It will never be incident on the mirror. So now, the other rule which is there, remember, there was one third rule in case of concave mirror, that when an object is incident passing from the center of curvature, okay, any ray of light, it was like this. Let me draw it separately. If any ray is incident from the direction of center of curvature onto the mirror, then the reflected ray also will be in the same line. Remember, this particular rule we will use here. So, this particular ray that I have taken, this is actually coming from where? See, where is it coming from? The center of curvature position. Okay. So, I am going to indicate it by drawing dotted lines. What does dotted line mean? Dotted line shows us that this particular incident ray is actually coming from which direction? From the direction of the center of curvature. Like here, it's from the center of curvature, but it is not starting from the center of curvature, it is starting from this particular point, but the direction is actually the direction of the center of curvature. So any ray of light coming from the direction of center of curvature will be reflected back in the same line. Alright? So it will get reflected back in the same line. Now, if it reflects back in the same line, let me show you the reflected ray. Is there any possibility that this particular reflected ray and this particular reflected ray will meet each other? Like in the previous cases that we had seen? No, they are actually diverging away. No chance for them to meet. So now in this case, what we will do? How to get the position of image? There has to be some kind of image, no, in this case. In this case, what we will do? We are going to prolong these reflected rays backward behind the mirror. And we will see whether they meet each other. Now remember, this is not the actual path of light. So we are going to show dotted lines. Actual path of light is given by full lines, but this is not the actual path. This is only drawn to get the position of image. So somewhere here it meets both these reflected rays, not actually but virtually. So when they meet, here the image will be formed. So let me prolong the position of principal axis, the line of the principal axis, so that I can explain. Here is the image of this particular object. So this is our object, and here is the image. Now this will be somewhere very far away, very far away. Like you remember the first case, the object used to be at infinity and the image was at focus. Now it is the reverse. Now the object is at focus and the image is somewhere at infinity. And see, actual size of the image is so big. Now this kind of image is called a virtual image. Actual images are where the reflected rays meet each other. Here the reflected rays, no chance of them to meet each other. So we have prolonged these rays backward somewhere and somewhere very far away from the actual position of the mirror they meet each other. Okay. So the position of image is at infinity when the object is at focus. The position of image is at infinity, very far away, somewhere very far away from this particular mirror, and it is behind the mirror. So let's write about the image. At infinity, it is very far away from the mirror. And the second characteristic is it is no more real and inverted. It is not inverted at all. See, the object and the image both are above the principal axis. So it is called erect or upright. Okay, and it is no more meeting the reflected rays no more meeting each other to form real image. So such kind of image are known as virtual and upright. Upright in Hindi we say सीधा. Okay, and the third characteristic is magnified, highly magnified. Highly magnified. You know what is the meaning of magnified? Meaning bigger. See the size of image is so bigger compared to the object. Okay, that's about it. These are the 5 positions of object for which the positions of image has been found out. Study these ray diagrams very carefully. You pause the video and see, draw the diagrams, because some of these diagrams I am going to ask in the exam also. But before you study these diagrams, you actually need to study those rules. I am again and again laying emphasis on studying the rules. So study those rules which we had done on the previous day, then only you will be able to understand. And in the next class, we will discuss about image formation using a convex mirror. Today we saw for concave mirror. Tomorrow or on the next class, we will see about convex mirror, how images is formed using a convex mirror. Thank you.